This is the post-lab video for the Newton's second law lab. We took a rock, actually, and we tied it to a force sensor on a cart, or a cart with a force sensor attached, and we measured the amount of acceleration compared to force. And when you do that, it gives you a slope, and the slope is lying along a line like this, the relationship if you go forward and backwards. And the slope is different depending on the rock, and the larger the rock, the greater the slope. So a best fit line would fit something like that. And so when we did it, the slope was entered here in the red, and the total mass of the rock and the cart system along with the force sensor was measured there. And these numbers don't look exactly the same, but when you take the average of these numbers over here and you look at the difference between them, the difference between them is quite small. So looking at these values, it says compare the class data. What do you think the slopes represent? And so the greater the mass, the greater the slope. And so the slope actually, in this case, was supposed to be mass. So the slope was equal to the mass. They were the same. So going down to the equation itself then, y is the vertical axis, and so we have force is equal to, and the slope m is actually m for mass, and then the x is the acceleration, so the horizontal axis is a, and then b, it should have crossed right there at 0, so there was no b. So that is proving Newton's second law. The relationship works out. The forces and the masses and the acceleration all lies along this plane, and it differs in this perfect slope. The greater the mass, the greater the slope, and it works out perfectly for demonstrating Newton's second law. Now we can take this and rearrange this equation to make it make more sense when we talk about the idea of acceleration. So what is acceleration? Acceleration is going to be the net force, or all the forces total up, divided by the mass. So the stronger the force, the more the acceleration. The larger the mass, the less the acceleration. So that leads us to the last idea here. Got a picture of Shaquille O'Neal, and he is in a vitamin water video riding a horse, and apparently the vitamin water gives him enough energy to win the horse race. However, we know that a real jockey usually is about 98 pounds, and the horse is massive and powerful compared to the jockey. So this gives us a real good example of the idea of the equation. If you have a large force and a small mass, of course you're going to get a greater acceleration, and you should actually be the winner of the race. If you have a large mass, then the acceleration will be less, of course. And this is only the winner in the world of vitamin water. So really, that wouldn't work. He would actually lose the race because he's too big. And that is the basic summary of Newton's second law, which oftentimes is written like this: F equals ma. But this is a really good representation of it because it allows us to talk about the idea of acceleration with respect to force and mass.